So we've all been there, right? You refresh your screen, and suddenly there's this whole new wave of AI buzzwords hitting you. Gen AI, LLMs, transformers. It really can feel impossible sometimes to distinguish the real signal from all the noise.
And that's exactly what we're trying to do today. Our mission here is really to cut through all that hype and focus on what feels like the single most important shift happening in AI right now.
Which is?
It's the move from systems that just, well, generate content to systems that actually execute outcomes. We're talking about the big transition from generative AI or Gen AI to agentic AI.
Okay, so let's nail down that core distinction right away. We're saying it's about moving from systems that just spit back a response to a prompt to systems that are actually designed to proactively pursue an outcome.
Exactly. Put really simply, generative AI writes the report for you. Agentic AI actually gets the job done.
Okay. So the difference between like delivering a draft versus delivering the final thing, the finished, maybe even tested product.
Precisely. And we can see this shift, this difference, really clearly defined if we look at 4 critical areas, or axes, you could say.
Right.
Things like reasoning, memory, tool use, and interaction. And these 4 things together basically form the mental model you need to choose the right kind of AI engine for the specific job you have in mind.
So understanding these factors isn't just about, picking a winner in some tech debate.
Not at all. It's about recognizing capability. If you really grasp those 4 points, you start to understand why Gen AI, which is powerful, don't get me wrong,
Sure.
but why it often sort of fails the moment real-world execution is needed, the moment it has to do something.
Okay, let's kick things off with generative AI then. Gen AI, the sophisticated content creator we've all gotten pretty used to over the last few years. It makes digital stuff, text, images, code based on a request, right?
Right.
And it really shines when the task is kind of singular contained.
Exactly. Gen AI thrives when the problem can be solved just by producing a static answer. Critically, without needing to interact with the messy, unpredictable outside world.
Yeah.
It's essentially a single-pass model. Prompt goes in, a response comes out. It's brilliant for drafting, summarizing, maybe transforming data, but all within that kind of contained loop.
But, and this is the key thing, the moment the job needs multiple steps or needs to use tools or needs feedback along the way, that single-pass model starts to break down.
It does, and that's where agentic AI is designed to step in. It's a system built to pursue complex goals, often with pretty limited supervision. You give it a high-level instruction.
Okay.
And it reasons about the sequence of actions needed to actually deliver on that instruction, that mandate.
So it's a fundamental change in the objective then. We're shifting from just wanting a high-quality deliverable like a piece of text to wanting successful delivery.
Yeah.
The agentic system actually closes the loop because its goal is finishing the task, not just answering the last prompt.
That's the core idea. It's about completion.
But hang on a sec. What about things like chain of thought prompting or recursive prompting? We've been trying to make LLMs plan and reason for a while now. Isn't agentic AI just, I don't know, a fancier name for better prompting techniques?
That's a really great question, actually, because it forces us to look past the marketing hype and at the underlying architecture. The difference isn't just about better prompting, it's about fundamental capability.
Okay.
And the core distinction, if we really break it down, lies in those 4 areas we mentioned. Maybe we can sort of compare them side by side.
Yeah, let's do that.
Okay, first, reasoning. For Gen AI, any reasoning is kind of implicit, almost instantaneous. It happens in that single pass.
Right.
For agentic AI, reasoning is about iterative planning and reflection. And crucially, this happens during the process, during inference. The agent actually uses compute time to stop, think, check its work, and verify things.
Got it. So it's more deliberate. What's next?
Second is interaction. Gen AI usually just talks back to the user who gave the prompt. Simple loop. Agentic AI, though, is built from the ground up to interact dynamically with tools, with different data sources, maybe even other agents, and with external systems out in the real world. It's designed to reach out and act.
Okay, reasoning, interaction.
No. Third, autonomy. This is a big one. Gen AI is entirely user-driven. You, the human, have to steer every single step.
Yep, prompt by prompt.
Exactly. Agentic AI, by its very design, is self-directed, though within predefined constraints, of course. You give it the high-level goal, and it manages the multi-step execution itself.
And the last one, you mentioned 4.
Right. The fourth is tool use, and this is absolutely critical. For a standard Gen AI model, using tools is often kind of bolted on, maybe an afterthought. For agentic AI, tool use is central. It's fundamental. Tools like APIs, web browsers, databases, code interpreters, these are the core mechanisms that bridge the gap between the language-based plan and actual physical action in the digital world. You could think of the LLM as the brain, but the tools are the hands and feet.
That makes a lot more sense now. The big limitation of Gen AI, then, is its inability to keep going through multiple steps and, crucially, adapt when things don't go perfectly, when the environment pushes back.
Precisely.
So if an agent is going to succeed where Gen AI often fails, it must need a more systematic architecture,
Right.
right? We probably need to look inside that agentic mind. You mentioned some essential components for this newer stack.
We did. And yes, there are really 5 essentials that make up the modern agentic stack. The first one is reasoning and decomposition.
Okay.
This is where we formalize that slow thinking capability we talked about. It involves the model explicitly breaking down the big high-level goal into a series of smaller, manageable subtasks. It creates a formal plan, and it constantly refines that plan as it goes. It's like making chain of thought much more robust and, well, mandatory for the process.
And I imagine that planning process relies pretty heavily on its ability to remember what it's doing and what it knows.
Absolutely. Which brings us straight to the second essential, memory and retrieval. An agent needs 2 kinds of memory, really.
2 kinds.
Yeah. First, you have short-term memory, which is basically the context window. And these are getting massive now, stretching into millions of tokens. That helps maintain coherence within the immediate task or session.
Right. Keeping track of the current conversation.
Exactly. And second, you need long-term retrieval. This is what gives the agent access to current facts, maybe private company data, or even lessons learned from past tasks. It provides that crucial continuity across different sessions or action sequences.
Okay, so it has a plan, it has memory and context. Now it needs to actually do things, which means tools, selection, and use.
That's the third one. Tools have to be treated as first-class citizens in the architecture. The agent's ability to orchestrate all these external systems, things like code interpreters, APIs for billing or scheduling, maybe a web browser for searching the latest info, that's what turns the language plan into real execution. It doesn't just invent stuff. It integrates existing capabilities.
But reality almost never goes according to plan, right? So the agent must need some way to self-correct when things go wrong.
That's absolutely vital. And that's where the fourth component comes in. Planning, search, and reflection. Plans get tested against reality, the results are checked, and then the plan gets revised if needed. We often rely on this pattern: plan, act, verify, and you repeat that loop until the goal is actually met. This reflective loop is maybe the key differentiator from simple Gen AI. It significantly cuts down on things like output hallucinations.
Oh, interesting.
And it catches errors because error checking becomes a native part of the workflow, not something bolted on afterwards.
Okay, plan, act, verify. And you said 5 essentials. What's the last piece?
The fifth is interaction and reinforcement learning. This essentially turns that reflection we just talked about into actual improvement over time. It learns based on feedback, maybe from a human supervisor, or maybe from the output of a tool like a code compiler, or even feedback from another AI agent.
Gotcha.
And when tasks get really complex, spanning multiple systems, that dynamic feedback mechanism is what transforms a static model into, well, a proactive worker that gets better.
Okay, that clarifies the how. Now, we've been using the terms agentic AI and AI agents almost interchangeably. Just to be crystal clear for you listening, what's the subtle difference there?
Good point. So agentic AI is really the discipline, the field, the whole philosophy of building these kinds of goal-seeking systems.
The big picture.
Right. Whereas AI agents are the concrete implementations. They are the specific units of work you actually build and deploy. An agent typically has a defined role, some rules it follows, a set of tools it can use, and an executable plan, all wrapped around that core LLM engine.
Okay, so one is the concept, the approach. The other is the actual piece of software doing the work.
You got it. Concept versus deliverable.
Okay, so if the agent is self-directed within constraints, as you said, then autonomy clearly isn't just an on or off switch, is it? It sounds more like a gradient, which seems incredibly useful for organizations trying to decide exactly how much control they're comfortable giving up.
It's absolutely essential to think of it as a gradient, especially when you're talking about actually implementing these things. We can actually map this out across, say, 5 distinct levels of autonomy, starting from, well, 0 autonomy.
Okay, let's walk through those levels. Level 0 would be no autonomy.
Right. Think classical machine learning. The model spits out a label or a prediction, maybe flags something as risky, but a human has to initiate the task, interpret that output, and then execute every single action based on it. The AI doesn't do anything beyond the prediction.
Got it. So level 1 would be assistive autonomy.
Exactly. And this is basically where generative AI sits today. It helps you draft that email or summarize that text, but you are still firmly in the pilot site, steering every single micro step of the process.
Right. Still lots of human effort involved. But you hinted the real business value starts to kind of explode in the middle levels, levels
Yeah.
2 and 3.
Yes, absolutely. This is what you might call the sane middle for most businesses right now. Level 2 is partial autonomy. It's often described as agent-oriented workflow. Here, the system can execute complex, multi-step tasks. But, and this is critical, it has explicit human oversight built in. There are verification checkpoints, maybe approval gates required before certain actions. Think of it like a smart cruise control in your car. It handles the highway driving, but it might ask you before it changes lanes or takes an exit.
Okay, that makes sense. Human in the loop, but the agent does more heavy lifting. What's level 3?
Level 3 is high autonomy, sometimes called goal-oriented collaboration. Now, the system achieves complex tasks with only occasional, quite broad human guidance, or maybe just safety guardrails in place. It's handling the long journey itself, maybe only flagging really unusual exceptions for you to look at.
And this is where you think most organizations can capture really transformative value today.
Yeah.
Because they get the automation, but can still maintain safety controls.
That's right. It strikes a good balance for many use cases.
So what's level 4 then? The top level.
Level 4 is full autonomy. This is where the system handles basically all steps within broad policy constraints. True autonomous decision-making. Now, while that's maybe the aspiration, most organizations realistically aren't touching level 4 much yet, except maybe in very controlled, low-risk internal sandbox environments. The stakes are just too high for most real-world applications right now.
Okay, that spectrum is really helpful. Let's try and ground this in some real-world applications.
Yeah.
When we talk about an agent closing the loop where Gen AI couldn't, what does that actually look like in practice? Give us an example.
Sure. Let's take automated software engineering. Imagine an agent gets a feature request ticket.
Okay.
It doesn't just draft some code. It analyzes the request, designs a plan, writes the necessary code modifications, then it executes the local unit tests. Maybe the tests fail. It reads the compiler error messages,
Oh, okay.
diagnoses the likely cause of the error, attempts a fix, retries the tests, and only when the tests pass does it package everything up and open a pull request for a human engineer to review.
Wow. Okay, that's huge. It managed the failure and self-corrected. Something a basic Gen AI prompt just wouldn't do on its own.
Exactly. That iterative plan, act, verify loop in action.
And I guess that translates directly to other complex fields like scientific discovery.
Absolutely. An agent could be tasked with investigating a research question. It could search through existing scientific literature, pull relevant data sets from different sources, script complex statistical analyses, and then maybe the initial analysis method breaks because the data is messier than expected.
Which happens all the time in research.
Constantly. So the agent can recognize that, adjust the analytical method, perhaps run alternative analyses, and then report back on the robust findings, explaining why it changed approach. It handles the messy reality without needing a human scientist to constantly intervene and debug.
Amazing. And what about for like everyday productivity? Maybe less complex, but still time-consuming tasks.
Yeah, think about complex coordination or planning tasks. Booking travel, for instance, or organizing a large event. You could give an agent a goal like, I need to be in Tokyo next week for a 3-day conference.
Okay.
The agent could then compare flight options across multiple airline websites or aggregators, check your existing calendar for conflicts, maybe fetch current visa requirements for Japan based on your nationality, potentially suggest backup routes if there are known delays, and finally, update your team's shared calendar once booked. It's the orchestration of all those previously separate manual steps that brings the value.
Okay, let's maybe address the elephant in the room here. Why did this shift happen now? Why couldn't we just keep building bigger and bigger Gen AI models to eventually handle all this execution stuff?
That's a key question. Fundamentally, Gen AI, even the really large models, ultimately hit a wall, primarily on reliability and frankly cost efficiency when tasks required sustained execution in the real world.
How so?
Well, prompts can get very long and complex, but they just don't effectively replace iterative planning and structured feedback loops for complex tasks. But what's really crucial here is the potential economic shift.
Ah, the money.
Right. Agentic systems offer a potentially different trade-off. They allow you to maybe trade using a single, massive, incredibly expensive model that tries to guess the entire answer instantly, for using perhaps a smaller, more affordable model that reasons longer, spending more compute time during the inference process itself, going through that plan, act, verify loop.
Interesting. So you're trading the potentially huge upfront cost of training and running a giant model for the cost of running more inference steps during execution, and that could potentially win out on both accuracy and price.
It's a definite possibility, and it's a key motivation behind developing these agentic frameworks. It offers a different path to scale AI capabilities, potentially more efficiently for certain kinds of problems. It fundamentally changes how we might calculate the ROI on AI investments for complex workflows.
Okay, that's a really important insight. So for you listening, if you're getting ready to potentially implement something like this, let's simplify the decision framework. How do you choose between sticking with Gen AI versus moving towards Agentic AI?
I think it boils down to the nature of the task. It can be pretty straightforward, actually.
Okay.
Pick generative AI when. The task is fundamentally a single prompt needing a clear, relatively static output. Think drafting an email, summarizing a document, maybe transforming data from one format to another. And when you prioritize speed and low latency for that single output over, say, deep reliability or multi-step execution.
That makes sense. Simple input, simple output. And when should you lean towards Agentic AI?
You pick agentic AI when the task inherently requires multi-step execution, especially across different tools, APIs, or systems. Or when you absolutely require high reliability, the kind that comes from built-in verification steps and maybe retrieval from knowledge bases. Basically, if you can clearly define the end goal and you're comfortable letting the system figure out the sequence of steps to get there, you should be looking at an agentic approach.
Right. Going back to your analogy, the LLM is the engine, but the agentic framework is the whole vehicle built around it, the chassis, the navigation system, the controls, the plan, the memory, the tools, and the driver, essentially.
Real way to put it.
But
Yeah.
giving the system more autonomy, letting it be the driver, that definitely raises the stakes, doesn't it? Yeah. If the system is executing actions in the real world, mistakes could have a much bigger blast radius than just getting some text wrong. What are the key risks teams need to plan for?
They absolutely need to plan for risks. The primary challenge, I think, is that specifying behavior is hard. Much harder than just writing a prompt.
How so?
Well, simply giving the agent a goal in natural language usually isn't enough for complex, high-stakes tasks. You need to invest serious design effort up front to clearly define the agent's specific role, the exact tools it's allowed to use, and maybe ones it's not allowed to use, the boundaries of its actions, and the specific guardrails or rules it must follow. That takes work.
Okay, so careful design is crucial. What else?
That complexity often means oversight is required, at least initially or for critical steps. You probably need to build explicit review points or human intervention gates into the agent's workflow, especially if you're operating in sensitive areas like finance, healthcare, or anything with regulatory implications. You need that ability for a human to step in, review, approve, or even pull the plug if necessary.
Right, the human safety net.
Exactly. And finally, maybe the least glamorous part, but absolutely essential. We have to address accountability. Just because an AI agent executes a task doesn't mean the human or the organization that deployed it is suddenly absolved of responsibility for the outcome.
Good point.
So this means investing in robust monitoring, detailed logging, and clear audit trails becomes non-negotiable. It's the necessary, if unglamorous, half of deploying agentic systems responsibly. #outro address.
Okay, this has been a really clarifying deep dive. I think the core shift is much clearer now. Agentic AI versus generative AI. It really is about moving beyond just getting ideas down on a page to enabling consequential actions out in the world. Generation gives you the content. Agency aims to give you goal completion.
Well said. And maybe for you, the listener, the best way to really internalize this mental model, this shift, is to actually try and deploy it, even in a small way.
What do you mean?
We'd encourage you to use this framework we've discussed, maybe even starting this week. Pick one process, just one, that you know wastes your team's time right now. Maybe it's a recurring research task they hate doing, or a complex coordination workflow that always causes delays, or perhaps reconciling data between two different systems.
Okay, find a pain point.
Exactly. Then try to write down the ultimate goal for that task. What does done look like? Then list out the tools, the software, the APIs, the data sources that an agent would theoretically need to use to complete that goal from start to finish.
And then think about how you'd measure success.
Precisely. Think about the real value. Would it be reduced cycle time? Lower error rates? A decrease in the amount of tedious human rework needed? Maybe even just higher satisfaction for the people who used to do that task manually?
Okay. Make it concrete.
That's the moment the concept really clicks, I find. When you actually watch an agent, even a simple one, you prototype close that loop successfully for the first time, that's when you fundamentally feel the difference between just asking for a draft and actually delegating completion. It's quite powerful.